start by asking one of the fundamental questions that we often find ourselves grappling with, which is, who is going to be our companion for the rest of the journey that we have on this planet through life? Most of us hope it will be a close loved one, a family member, and a large amount of our time is spent invested in ensuring the health and well-being and happiness of that loved one or family member or dear friend, so that we have a companion besides us as we journey through life. But the reality is that that's not a guarantee. You hope that you will have a companion who walks alongside you, but that may or may not happen. We then look within ourselves and ask, what about us? Hopefully, we are our own companions as we navigate life. And if you think about it, we are eventually just carbon, hydrogen, nitrogen, sulfur atoms put together largely to put together this individual. Our bone replaces itself every 3 months. You're shedding your skin as I speak. Okay? Certainly, none of you here has the same skin, the same hematopoietic blood cells in your body that you had when you were born. So who then are you? You're now a conglomerate of cells that didn't exist when you were a single cell embryo. So who then are your genuine companions? Who can you count on to stay with you for the rest of your life till the day you breathe your last? Well, there's one cell group that will live with you. Pretty much very soon after your conception till the day you die, and those are the nerve cells in your brain, your neurons. So the only real, genuine, constant companion we have as we walk and navigate through life are our brain cells. How much time do we spend looking into their health, nutrition, well-being, and livelihood, because they truly are our constant companions as we navigate through life? This is something that's worth thinking about. And you would have heard the standard grandmother's tale that tells you better look after your nerve cells, because if you do something terrible to them and you lose a few, you're not going to be able to replace them. You don't worry similarly about your skin. Certainly all the people who are getting all these glycolytic peels, etc., are ripping off their cells on their face on a regular basis and shedding them left, right, and center, not worrying about the fact that, oh, what if I lose them and they don't come back? Your skin cells do come back. What if you do something to a large number of your nerve cells in your brain? Will they come back? Well, the general dogma in the field was that no. What you're born with in terms of neurons and what you eventually have by the time you're a 2-year-old toddler is pretty much all you're going to have in terms of hopefully most of those hang in there with you as you get older. And the more that they hang in with you, the more likely you're going to be able to stave off cognitive decline, Parkinson's disease, Alzheimer's disease. So you really want to look after those cells, and that was the dogma. What I want to tell you is that as early as a discovery in the early 1960s by Gopal Das and Joseph Altman, we knew that there were pockets in the brain where this rule did not apply. The idea that you might make newborn neurons throughout life was heretical in a sense. Everybody thought the brain was special. Sure, the liver replaces itself every now and then. Sure, the skin, in fact, replaces itself within weeks, but not the brain. Brain cells are super special. Why would you be replacing and regenerating parts of your nervous system? And so the general idea was there's no way you would be able to actually make newborn neurons in your adult brain. However, that's not the case. There are very special, unique places within the brain where cells like these, and these are stem cells, and they're labeled green because they're genetically marked with a protein that fluoresces green when hit upon by the right wavelength of light. And so you can see these stem cells in the brain. You can watch them. You can see them divide, and you can see them become mature neurons. So now you're going to ask me, oh my God, okay, so all right, the brain actually has the ability, not everywhere, but in special pockets to keep on making neurons throughout life. Why does this matter to anyone in this audience? Or is this just some esoteric scientific discovery that's going to get written up in a journal and people like me and others in my community will discuss it, but perhaps will really not have an impact on the public at large? Well, it turns out that it's not just us. Okay? There are several species. Our cousins, our very near cousins, the monkeys, our more distant cousins, and our far further distant cousins on the evolutionary ladder clearly have the ability to generate new neurons. This is where we found out most about them initially in the 70s and 80s from songbirds where it was discovered that as you learn a new song every season to woo your partner, you're actually making new neurons in the brain and making new connections as you produce that beautiful same song to find your spouse or partner in for the bird, okay? It's true for the frog, and certainly the salamander and newt have got it much better than us. If you lop off, and many of you have probably by mistake knocked off the tail of a lizard or unfortunately the forearm of a lizard, and soon enough, a few weeks later, you see the lizard back with its forearm running around. We've lost that capacity, but not newts and salamanders and lizards. Rodents, tree shrews, who are sort of halfway on that evolutionary ladder between our cousins and us, the primates and the rodents, all of these make newborn neurons. And we knew this by the time this was well into the 90s, that there are pockets in the brain of all these different species that retain the capacity to keep making new neurons throughout life. Well, we thought we were special, and we often tend to do that. We've liked putting ourselves at the pinnacle of the ladder of evolution when we are actually a very recent experiment in evolution and not a very successful one at that. If you think about the entire year as the time of life on Earth, then we've been born in the last second of that entire year. We haven't proven that we actually can hang in there. The cockroaches are doing a far better job of proving themselves as evolutionary successful. We are just a recent experiment in biological evolutionary history. So we thought we were special, and perhaps we didn't actually have newborn neurons. Maybe it was just lower vertebrates and other mammals. But that idea clearly proved not to be the case, because the same pockets that make newborn neurons, these neurogenic niches, neurogenic because they have the ability to generate or cause the genesis of new neurons. One place being the hippocampus, and I'll tell you about that in a few minutes. And the other place, the ventricular zone that makes newborn neurons in the olfactory bulb. Okay? Turns out our cousins also have the ability to make new neurons throughout life. Our more closely related cousins, and this is work that came from Elizabeth Gould at Princeton, our closely related cousins are adding new cells in their hippocampus, and so are our more distant cousins, the marmoset in this particular case. And yet we hung on to the view that we must be special and different. We are the ordained top of the evolutionary ladder. Perhaps it's just in us that we don't make newborn neurons. And that clearly is not the case, because in this paper in 1998, it became apparent that the human brain also has the capacity to generate new neurons throughout life in very special individual pockets. So right there are cells that have just been born and then go on to become neurons in a region of the brain called the hippocampus. Why does this matter to you? You're sitting in this audience wondering, how is this remotely relevant to me? Why should I care if there is a pocket or a niche in the brain where new neurons are dividing and new neurons are being born? Well, that's good. My skin's been replacing itself quite happily for years, and I never needed to know about it. Why should I worry about whether new neurons are being generated? Turns out it's really interesting to ask what these new neurons and regions of the brain respond to. They really care about what you do with yourself. If you are using your hippocampus to actively learn, then more cells are being born in the brain and much more new neuron generation is going on. If you're actively engaged in physical exercise, and it better be voluntary and not forced, because it turns out when it's forced exercise, it doesn't work as well. But when it's voluntary exercise, then you have a profound increase in newborn neuron generation, and not only do you generate more neurons, many more of those like the idea of hanging around in an exercising brain. And I mean exercise physically here. There's obviously the component of mental exercise, which is pushing yourself out of your comfort zone. If you're regularly pushing yourself out of your comfort zone, you're adding new neurons. It is critical that you be pushing yourself out of your comfort zone. If you're doing the very same thing over and over again, eventually it just becomes habit. Okay? But when you push yourself beyond that boundary, you're adding new neurons to the brain. You're also doing it when your environment is substantially complex, enriched, novel, both socially, both in terms of the challenges that you're likely to see and your capacity to buffer those challenges. So if you take animal models like rodents and put them in very enriched, interesting environments where they have cages to run through, little mazes to find things in, friends to play around with, and a different set of friends to play around with very often, well, those animals end up with as many as 40,000 more neurons in their hippocampi. That's substantial. That's about 2 million cells in there for the rodent brain. Okay? We're talking about 100 billion neurons in our brain, several more in our hippocampus. But it's likely that the very same things that affect our cousins likely affect us as well. And why do we know this? Because now we have substantial clinical data that indicates that how active your life has been, intellectually, creatively, and physically, is likely to be a predictor of your aging-associated decline and the possible onset of mild cognitive impairment, senile dementia, and Alzheimer's disease. So what you do with your nervous system actually does matter. On the other hand, okay, and if you look at this, a set of drugs that unfortunately humanity is now more and more dependent on, because we've created a fairly complex social world in which we have an increasing rate of depression and anxiety, both disorders that are often treated with this pharmacological group of drugs called antidepressants, like Prozac, for example. Turns out, every antidepressant that's out there in the market, when given chronically, also increases new birth and new neuron generation. However, it's important to note that drugs like that, of course, come with their side effects. Perhaps there are less side effects up here on that side. So physical exercise, enriched environment, active novel learning could help you push back the onset of a variety of neurological and psychiatric diseases, then perhaps this is actually information that should not be languishing in an esoteric scientific journal, but out there for the tax-paying public that paid for this research to be done. And let's look at what's on the other side of that. Stress, animal models of depression, and the natural process of aging causes the birth of these newborn neurons to precipitously decline. And over time, you have far fewer neurons added to your brain, far fewer entering and networking within your nervous system. And why does this start to matter to you? Well, this should matter to you. This should matter to you because you often, and every single one of us in this room, often worries about who's going to be beside our side when we are breathing our last. It's a thought that we try to push off, but it's a thought that often at 3 o'clock in the morning, if you happen to be awake and lying in bed, comes into your mind and you wonder, I hope I'll be surrounded by my loved ones, by my family. But I can guarantee that there's no guarantee that that will happen. But there is one guarantee. You'll be surrounded by your neurons. You definitely will have your neurons with you. And perhaps the nature of life you will have navigated as a sentient being will be richer if you look after those neurons as you navigate our time on this planet. And so the reason why I think it's important that this research gets out to the world at large is that newborn neuron generation is exquisitely sensitive to the nature of environment that the animal or the organism is in. You have a way to regulate it, and it is not just drugs. What you do every single day has the profound ability to change new neuron generation. The likelihood that those new neurons will stick around to take part in your circuits and contribute to function. Learning, so certainly pushing yourself to do something new, perhaps learning a new language, maybe picking up an instrument that you've never played in your entire life. That's really pushing the boundary. Learning a language gets harder and harder as you get older. Certainly, learning to play a musical instrument is not going to be easy. But when you challenge yourself truly with novelty that you would not normally push yourself with, you drive new neuron generation in your brain. So maybe those, physical exercise, etc., should become early companions in our journey through life, because there's often an axiom that neuroscientists use, and it's one that's entered the routine lay public as well, which is use it or lose it. Our neurons are our companions throughout life. The youngest ones, the ones that get added every single day, really care about what you're doing with yourself. So perhaps, in addition to all the time that we spend on this planet, looking after our companions who will accompany us as we navigate our time on this planet, we might want to spend a little bit of time thinking about how we might look after those little tiny 20 micron to 30 micron cells that are constant companions through life, and create a local small microenvironment for them in the brain where they thrive, do incredibly well, and stand by you as you navigate your time on this planet and in this space. That's what I have to say. Thank you very much.